Hi everyone. We're going to talk about sigma and pi bonds in this video. Remember, this is the symbol for sigma. And as you can see here, there are three ways that we can make a sigma bond. The first is the overlap of two s orbitals. So we could sketch that. First of all, this is the nucleus of one atom, and here is its s orbital. And here is the nucleus of another atom along with its s orbital. If these two were to overlap, this is what we'd have. Right here, where those two s orbitals overlap, we would have ourselves a sigma bond. Now, just as a reference, I'm going to draw the internuclear axis in between our two atoms. Here it is. And here it is here. This is the internuclear axis between the two atoms, or more specifically, between the nuclei of those two atoms, internuclear axis. Notice that our sigma bond is directly on the internuclear axis right there. Let's look at another way to draw a sigma bond, or to create a sigma bond. We can have the overlap of an s orbital and a p orbital. So here is the nucleus of one atom, here is its s orbital, here is the nucleus of another atom, and here is its p orbital. When these two overlap, you do get a sigma bond. Here is our sigma bond. We call this type of overlap a head-on overlap. And just as a reference, let me sketch that internuclear axis. There it is. And there it is again. That's just the imaginary line between the nuclei of our two atoms. And notice again that the sigma bond is directly on that internuclear axis. We've got one more sigma bond to draw, or to create. And here it is, the head-on overlap of two p orbitals. Well, here we go. Here is the nucleus of one atom. Here is its p orbital. Here is the nucleus of another atom, and here is its p orbital. When these two overlap in this so-called head-on fashion, this is what we get. Look at that. There is your sigma bond. And notice again that the bond is located right on that internuclear axis. So what are the key features of a sigma bond? First, we could say that the bond is directly on the internuclear axis, and that makes the bond stronger, or the sigma bond stronger than a pi bond, and that allows the atoms to rotate around the internuclear axis. So both of our atoms can rotate around that internuclear axis. Let me show you what I mean. I've got an atom in this hand. The nucleus is in the very center of this s orbital, and I've got an atom in this hand. Its nucleus is in the very center of its s orbital. When these two atoms come close enough together, a sigma bond is formed. And imagine that internuclear axis. Look what these atoms can do. They can rotate around that internuclear axis. Pi bonds can't do that. Well, we saw 3 ways to make a sigma bond. There's only one way to make a pi bond, and you probably know that that's the symbol for pi. It's the side-to-side overlap of 2 p orbitals. So here's the nucleus of one atom, here is a p orbital, here is the nucleus of another atom, here is a p orbital, and when these two get close enough together, their p orbitals overlap, and we end up with a pi bond. Here's a figure from your book. Again, you can sort of see that this is where the p orbitals were, but when they overlap, you get a pi bond. Notice where the pi bond is located. If this is my internuclear axis, and you see it here too, the pi bond is located above and below that internuclear axis. So that's one key feature of a pi bond, that the bond is above and below the internuclear axis, and that makes pi bonds weaker than sigma bonds. And because you have overlap above and below that internuclear axis, these atoms are not allowed to rotate around it. And that means that pi bonds are more rigid than sigma bonds. Let me show you what I mean. Remember how in a sigma bond, the atoms could rotate around that internuclear axis? That's not true in a pi bond. In a pi bond, the bond is located below and above the internuclear axis. So this scarf represents the bond below the internuclear axis, and if this is all I had, I might be able to rotate an atom around that internuclear axis, but I don't. The bond is also located above the internuclear axis, represented by this scarf here. Now when I try to rotate my atoms around that internuclear axis, I can't.